So recently I decided to get an M1 Mac because I always said if there was a decent ARM-based computer that was capable of doing all the things I needed, I would rather switch to that. As part of that, I started installing things to get my Mac to be capable of doing embedded development. I do generally bare metal embedded development. And one of the things that I've been recently working with is a program called Renode. And I did work with it some on Linux and got it to work on Linux for simulation of embedded firmware for bare metal. And I grabbed that configuration file information and stuff and moved it over to my Mac. And one of the things I was having a problem with on dealing with it was that I wasn't able to get this to work with CLion. I moved over to CLion because it allowed me to do all of my C++ development, C development stuff inside of it, whether it was for the embedded side or it was for the Linux server side or whatever. And so having one environment that can do everything that I want is really good. It's really time efficient because, you know, one set of key commands, one set of configuration, one set of getting used to, an IDE or an editor. So what I got working recently, which I wanted to do a little video of to show you what I did in case somebody else is trying to do this out there, was I was able to get Renode to work integrated with the debugger inside of JetBrains CLion here. So I can just hit debug Renode instance and step right into the firmware that I'm trying to work on. Don't need to power up a power supply, don't need to have the board hooked up, don't need to have my Seger hooked up, don't need any of that. I can just debug the code that will run on the board or on the chip to the best of my abilities in real time, all off of my machine. And in order to, show you how to do that, I have to explain some stuff. So I have a Renode config file here that tells Renode what to do on startup, and I had to add paths, verbose paths, to exactly what I needed to run and where it was located. So maybe later I'll find a better way to do this. Maybe I can script something that does current working directory and then whatever, I don't know. But right now it works, and I'm only developing on my Mac right now for embedded firmware, so I don't really care. That's how it is right now. So there's the firmware that's going to run, and this is the script that builds this core node. The core node consists of the definition for the processor that I'm using, which is here. And this definition needs an SVD file archive, which that had to be modded to have the direct path to where it was. I was easily able to use local paths on Linux, but I was never able to get this to run inside of the debugger setup and have a target here on Linux because I didn't try it. So I probably would need verbose paths there as well, right? Core node also has this core coupled memory config, which is this here. I separated that out in case I wanted to use a chip that didn't have core coupled memory defined, so I could remove it and change whatever I needed to. So that's the config files that works for my system. Just remember, whenever you're putting in a firmware binary or you're putting in a path to another node, you have to have the verbose path of where it literally exists on the machine. So that all being said, all that stuff there, and obviously you set up your breakpoints where you want to be. Now here's the interesting thing. So I used an embedded GDB server config to do this, and obviously the target is going to be all, I want to build all the firmware so it generates my executable. I'm going to use the bundled GDB because it's multiple architectures. And then I only want to download the executable when it's been updated. So what that does is when I change something and save the file, the executable will be rebuilt, it'll be updated, and that's when it should re-download. This will save you flash writes on your dev board or your production board or whatever you're doing. Not that it really matters because Flash has so many writes nowadays. These boards are years old and I've been playing with them forever and they still have writes. They might fail someday, but it ain't going to be anytime soon. Now Mono Mono will run the debugger on the file's not open. Mono will run the debugger on the port that you define here. So I chose 3333, right? So when you do this, you need to make sure that your target remote arguments are localhost : and the port you defined, right? Now here's the weirdness. So the GDB server is what it's going to start up. It's the program it starts up. So I just threw the Mono executable in there. And then with Mono, in order to run Renode, you have to run Renode exe under Mono. So that's the first GDB server arg. So it's Mono and then the absolute path to the Renode exe. And then everything after that will get passed to Renode. So I added my configuration file. And so adding my configuration file, bam. It starts Mono. Mono loads Renode. Renode gets this config file and it should start up. It works very well. And I'll show you that in a minute. Monitor reset like normal after you download, and my startup delay is 0. I just wanted to make sure you saw all the possible configurations here that would, might be needed to get this to work. So now I'm just going to hit debug, and when I do that, Renode will start up. It just takes it a minute because it's got to run Mono, then it's got to load the Renode executable and stuff, and there it goes. It's started. And then my config file, operation timed out. Why would it time out? Well, that sucks. So let's see, maybe I need some kind of delay. If it's not one thing, it's another, right? So let's do ½ a second delay. Maybe that's what it is. Maybe it's not built. Oh, it's built. Okay. I just had this working. This is funny. So yeah, so should start up. It should connect. There it goes. So then, you type start to start the simulation. As soon as I do, I drop in to to where my first breakpoint is, and you can you can step into it, and look at stuff. It will provide all the information you need. It's pretty cool. Just works. And CLion just sees it as a valid GDB server. And you can run it and it just works. So say I add this counter, and then I say, if the counter, well, that's a bad way to do it. if it's 100,000 is equal to the counter, then we'll say counter 0, right? So we're only going to count to 100,000. And I do this. This is one of those things I do so that if I accidentally type if I type just equals, your left-hand value can't be set to a variable. You can't do that. It can only work like that on comparison. So so I've changed code, right? And we'll do that. So we'll set a breakpoint here, right? And we should be able to just hit debug in the Renode instance. It should recompile, start everything up, and we should be able to just go ahead and debug. So there's Renode. Pop up the main console, hit start, hits my breakpoint. I remove that breakpoint because I don't really need that, and resume. And it hasn't hit it yet, so we'll see. Should count fairly fast, I would guess. There we go. Counter is at 1,000, and we'll step through. Counter plus plus, so counter is 1. It's not 100,000, and it'll keep going. So you can hit stop here, or you can type quit here. Both will stop it from debugging, so I'm just going to do that, close everything out. So I'm guessing, I'm going to go ahead and guess that I needed this delay of ½ second, probably because I'm recording this video. I had it set to 0 when I wasn't, and it started right up. It didn't time out. Everything worked fine, but most likely because I'm doing this video to show you how to get this to work, you know, it probably needed a ½ second to make sure that everything was started up and was running when it went to connect to Renode to debug this. So yeah, so there you go. There's how you can hook Renode up to CLion and do your embedded development directly off your machine. So hope it helps you. Bye.